But a lot of simple materials. For a lot of simple materials, let me put it that way. Truly elegant structure goes a long way towards reducing cost, and rammed earth is a great example of that. Any questions? Woo!
Good. It seems that an advantage of your layering thing that you just showed us is potentially greater thermal performance.
Certainly that is a thought we have on particularly with Portland. If we were to do it the same way, we would not be inhibiting the hydrothermal benefits of Portland with less Portland in there. But I suspect the same is true of mine also. We haven't proved that. What we have proved is this. We've done limited sample testing on this. In order to test this block at scale, we would need a 300-pound press, or we would need a really well-behaved stack of 181 well-equipped Honda Civics, which, as a fun visual fact, would be 150 feet taller than the Tower of the Americas.
Do you have a sample?
Well, I don't have a sample of that. Oh, yeah, well, okay. We didn't get to that part. That's okay. I don't want to run past the 20 minutes on the first thing. We had some show and tell, but
Oh, come on.
well,
Well, if they want that instead of questions, that's good.
getting to 600 feet, the point was is that durability and durability and compressive strength are not the same thing. They have some allies, they kind of dress alike, but they're like drinking buddies with a complicated relationship. You know, getting to 600 pounds PSI in unstabilized work, that's not technically challenging. That's mixed design 101. This little guy here is unstabilized. We can make them all day long by the truckload, and they will break at 2,800 to 3,000 pounds. I smell a lot of skepticism, but it's true. It's also a parlor trick. We mess around with not only the particle size distribution, but we're using boron nitrates and diatomaceous earth instead of leaving it with silt. We're using aluminum oxides and crushed glass instead of sand. And why use nice smooth pea gravel when you have blocky decomposed granite goes into the mix. We're just basically playing with mechanical binding here. It's just a different way of stabilizing though. But this is to prove a point. You can get to 600 PSI easy. That's mixed design 101.
Those modules, are those available in the United States yet?
Yeah, yes, they are. we prototyped them. Yeah. We're on our second generation prototypes of the modules, enough to prove that it can work. We have some refinements we want to do, but it's ready to go.
Ron, you made a very intriguing statement that the modular forms have a lot of potential for reducing costs to making residential construction for affordable housing and for middle class homes more affordable. Have you any done any residential construction with it?
This is a brand new process.
Okay, all right,
Yeah.
very good.
That's
So it'd be very interesting to think about doing a demonstration project someplace.
we hope to do.
And that's why we want to talk to a group like this where you can give us feedback on.
Yeah, we have.
Would you
What we're looking for
consider
now is
this kind
feedback
of
from architects,
process?
engineers,
You know,
interested
what would you
teachers,
be looking
arranged,
for
you know.
in a process like that?
I apologize for coming in late, so you maybe already talked about this, so don't repeat it if you have, but how are the panels joined in a way to give a more of a
Well,
they
they can have indexing features. This is going to be, part of this is going to be up to the engineer and the architect. Some of it will be driven by design, some of it will be driven by engineering. But they can definitely be mortared, and the mortar can either show or not show. On the bedding joints, that is the joints that are horizontal. We can blend those and make it look like a monolithic wall. They did that with the Ricola project, but you can't do that very well. At least we haven't figured out a way yet to do it on what's called the head joints or the vertical joints. So if we can get a panel the width of a wall, we can make it look monolithic. Otherwise, we imagine using the joints in the blocks as part of the design element, which is one of the cost savings also. It lets us do away almost entirely with volume displacement boxes, which are huge time sucks. So well, that's what you put in place to make a window or a door or something. We can get rid of that by forming blocks right according to plan. Because we're also developing a software that drives all this from the design drawings through 3D printed architectural models, through the form assembly, plans for the job site, even that drives the CNC machines that machine the parts for the forms. So,
But is there any physical key?
just, there can be, yes,
Okay.
yes.
And how thick are the walls?
That's the beauty of the system. The walls are as thick as your engineer, architect, and or homeowner wants them to be. There are codes that govern unreinforced wall thicknesses, and it's a ratio to the height that's 10 to 1. So, you know, that is, if the wall is intended to be a structural wall, then you're going to run into that limitation.
What about the shapes of the walls? What kind of flexibility do you have?
If it'll fit, right now our pallets, our forming pallets, I call them pallets, they're very fancy machined metal bases. Their forming pallets are 3 by 5 feet, so we can turn a corner on that, and that, again, that's driven by the weight of the blocks. The machine that we want to use to place it is a small telehandler because it's very maneuverable. But other size blocks will probably come later with other ways of setting them, cranes and stuff like that.
But you can have
Curves,
whatever curves you want.
warps, yeah, we can essentially, I would bet that if you can think it up, we can pull it off. So, and now, that's gonna affect the cost. Obviously, the title of this is a, you know, I don't wanna talk anybody out of nice, simple, you know, blocks where rectangles work really well, curved sections work pretty well. You could show her the slide of the blocks and she may understand the indexing. I'm sorry,
Other direction.
See, this would have a mating block. This one that shows it on. We can cast those in there, and they can be however the engineer decides he wants to see them. So, anybody else?
Question, as far as from work day to the next, how do you start and stop? As far as when you're doing your construction, is there any procedure that you have to use to bind the next day or start the next day, be able to keep going?
If you're talking about conventional rammed earth, you have to pay attention to cold joints. You profile them differently at the top of the joints. With these, you would not want to put mortar on top of a block unless you were going to put the next block on top. So you would leave unmortared surfaces at the top and at the sides.
You didn't say it, but I'm assuming that you can include, if I wanna have an engaged steel plate that I'm going to then weld something else
Yes.
onto,
Yes.
you could put that into your formwork like you would with concrete and compress around it.
Yes, we're big advocates of embedding when you can if you're going to attach walls. We have a complete machine shop. We do our own form building, our own form and embeds and lintels and stuff like that because we know the most about rammed earth, about how it's going to go in. It's just a lot more efficient for us to do it, and we always advocate if you can get something. I don't want to see plumbing pipes in the wall. If you can advertise attachment, if you can embed attachment structures into the wall, that's your best bet.
Cool.
The downside of that is, that, you know, once it's done, they're set in stone, literally. So.
Right.
So the city's in the process of updating its UDC codes. Are there some examples that we can look at or help shape for a more rammed earth friendly UDC?
Gosh, that's probably a question for Steve. And actually, we can point out examples of rammed earth houses in the area. Certainly in Austin, Georgetown, we've got 2, 3, 4 there, another 2, 3 on the drawing boards there. They're close enough to make a difference. And also, there are municipalities that have adopted that are, you know, perfectly open to rammed earth construction. But he would be the wizard on this.
You know, there are some examples. There's even one on Woodlawn, which is a clay structure that was done in the 20s, I believe. And so they're about. But it's easy. For those of you who don't know, you know, Mr. Trevino here is a councilman and an architect. And so you have a lot of people here at your disposal to help you out. Believe me. So I'd like to help out with that.
Yeah, well, I think, you know, I just bring up the point that, you know, sometimes we have, we develop codes and regulations for a very specific reason that can sometimes limit some choices that people can have. And so I guess I'm just kind of curious what we can do, since we're in the process of updating our UDC, that this would be the right time to introduce some of that language so that we can be more friendly.
Well, Mike Shannon has been very helpful
Good.
at the Development Services. The project that I brought before you, and you were helpful also because it was in your district, they made it much easier for us. And they, instead of putting up a lot of roadblocks, they said, how can we get to you guys? Can you answer this question? What do we do about this part of the code? And we were able to show those answers a piece at a time, which even though it was a little more onerous than conventional, was a lot smoother than I expected. And so a lot of the pieces are already in place, city-wise and development services-wise. But UDC, I'd like to see some changes in that. That would be dynamite.
And in addition to that, we are in the process of revamping or taking a new look at our incentives, specifically to housing. And so this is also the right time. So yes, I definitely want to hear
Definitely
more
got
about.
a proposal for that.
Okay, great.
So it's the internal square footage if you're building a plant-friendly structure rather than the outer, because you're penalized for the healthy walls.
Okay.
But, I'm just a neophyte on it. These folks know a lot more about it.
Well, by the way, my email is simple. It's roberto.trevino@sanantonio.gov. I would love to hear from you. This is the time to do it. From UDC code changes to our incentive packages. This would be a great time to also introduce this in terms of our incentives. If we really want to push innovative thinking and unique construction methodologies, it would be good for our incentive packages as well.
Can I toss something out in that line of thinking? I've sat in on some of the meetings where they're reviewing the code, and part of the reason difficulty in fitting these conversations together is that the code review process is reviewing the new codes that are coming out based on the old codes and changing a little bit of language here and there and deciding what stuff on paper that already exists wants to be adopted. Part of the deal with this is there's plenty of examples of the construction that exists that has persisted over time, but there's not a lot of precedents set on paper. A little bit out of New Mexico, but there's just not a whole lot that's happening. I think what this group needs from some of the conversations I've heard is help establishing those things. So if the city had a process that says there's no incentive, there's no precedence for any of this kind of stuff, but if you work with Southwest Research Center to show that what you're proposing has these particular properties or has meets this performance criteria, then we can be the first to write the code that governs this.
I like that, and in fact, I would add that we've created a new council committee called Innovation and Technology. And I think we could bring some of these ideas to that committee so that council members can, from a policy direction, help move some of that forward. So I like that. I think that we definitely are looking forward to providing some some direction for innovation in our city through that committee. So I certainly welcome further discussion, and maybe we can arrange a presentation to that committee.
That'd be awesome.
Well, one of the things too, I'm glad you brought that up, and I'm glad you brought that up because at ECI, Earthen Construction Initiative, we have a research arm. Michael Donahue is very big in that. They've already discovered a lot of earthen codes that are around the world, such as New Zealand and Chile, where they even have to worry about earthquakes because of the Ring of Fire, and lots of different kind of climatological areas too. Earthen construction is very big in Europe, very big in China. Some of the oldest structures, of course, that are still operating are earthen structures. And the nearest oldest one is probably Taos Pueblo. It's at least 900 years old, still no air conditioning.
Right.
And so there's aspects of it, not only structurally and durability, the buzzword now is what, resiliency?
Right.
You don't get much more resilient than earthen structures. You know, this is
Right.
something for the ages. Okay? And so what we're doing with the research arm is finding that kind of stuff out. Also discovering some very intriguing things about earthen construction, the hygroscopic aspect, where these structures are actually modifying temperature and humidity. So that eventually, once that research goes far enough, we can influence mechanical engineering design. So that when you do a manual J calculation, instead of a 5-ton AC unit, maybe a 1-ton, maybe all you need is a dehumidifier in certain climates. And so these are the things that we're dedicated to do. And would like to invite all of you to be members.
And tell them when we meet. We meet the first Tuesday
First Tuesday.
of every month here at the Southwest School of Arts at 6 p.m. There's a business meeting from 6 to 7 and then the presentation at 7 there afterwards.
And we will have more chairs.
Yeah. So, leading off of the hygroscopic, we'll do a plug for next month's presentation. Tim White will be presenting, and it's he's going to be talking about the power of water and clay, phase change materials, and I guess he wants to.
2 minutes.
Okay.
So there's a professor that used to teach here in San Antonio, and then he became a junior college professor out in Del Rio, Texas, named John Maroney. And John was the first one that actually started to look at what is this thing that we're feeling when we walk into an old adobe house, and it's cool and it's 110 degrees outside. Meanwhile, you walk over to Jose's house and it's a concrete block building and it's 110 degrees, and they're all sleeping outside because nobody can stand to be inside of it. Okay? And so he came up with the idea and the theory that the hygroscopic and hygroscopic properties of the clay platelet itself, and it's carrying a negative ionic charge, is able to interact with the thermal energy of water at vaporization. And so John and I have published a couple of papers through the USA Adobe Association that meets every other year in Santa Fe, or in Albuquerque now, or
Earth
Santa
USA.
Fe now.
Yeah.
2 years ago, when my daughter was a 7th grader, she was trying to figure out what to do for a science fair experiment. And John and I had talked about how do we take this from building houses or small units into something that's simple and easy to reproduce. 10 years ago, when I was at a Hempcrete Lime Symposium and had a chance to sit down with Bruce King, and Bruce King has the new book up, Beverly.
Yes.
You have that?
Carbon architecture?
And Beverly has a copy of that. All of you architects need to get one of these, because the new carbon architecture is about not looking at how big of a fancy of a building that we can build. It's about looking at what is the embodied energy of that building material going into that building. There was an architect that I met when I was doing a presentation on Roman cement in Colorado, and he was looking at the embodied energy of the building materials, how the energy savings come from those building materials, and where is the energy that goes in, and then where is that energy that's been saved to make a break-even point. His research was coming in that straw bale and papercrete were all like 18 months to 24 months. And his research in insulated concrete form with foam, plastic, concrete, and steel was at the 43 to 45 year zone. And so it's a super green building material because of its longevity and its foam and it's insulated. But if you really get down to the heart of it, what's taking place there? So my daughter asked her science teacher in 7th grade, what should I do? And she's like, you should go talk to your father and see some of the research that he's doing. So she came up with and put together this little experiment that I'm going to bring next month. We call it the Maroney experiment. It's about this big. It involves petri dishes and a triple beam balance scale. And next month I'm going to dumb it down so far for us all that we're not going to even use technology for the presentation. Okay? But in her little thing that she took to the science fair, she got an award. She got the right sustainability award for the science fair experiment that may lead to actually a sustainable world. Okay? In that, it looks at those petri dishes and comparing basically their weight in the morning when it's a higher humidity to the weight in the evening at a lower humidity. Anytime that material is taken on or giving off, The only way that it can interact with anything in its environment is through water vapor, or the thermal energy of water at steam. And there's a whole latent heat flux and a latent heat zone that takes place inside of that, and we'll cover that in detail next month. Thank you
Excellent.
all for your interest in earthen building and looking at the future that we all want to